Now we're going to be using our simplifying radicals in our similarity in right triangles. The similarity in right triangles, what we're going to be looking at, obviously, are right triangles that are similar to one another in the fact they are proportionate. But we're also going to be doing something where we're finding the geometric mean. Now, usually we think of mean as being the average of two numbers. But actually, the geometric mean is going to be helping us find the length of the altitude within a right triangle. Now, the altitude that we are finding is going from the actual right angle to the hypotenuse of this big triangle. Now, when this happens, when we create this altitude, it actually creates three triangles that are similar to one another. The big triangle, ACB, the small triangle, ACD, and the middle triangle, CDB, are all similar to each other, proportionate. So from there, we can figure out different side lengths within this right triangle. So the definition of a geometric mean is here. It's the length of CD, which is this altitude. That's the geometric mean of the lengths of the segments of the hypotenuse. Okay, it's the altitude is the geometric mean of the lengths of the segments of the hypotenuse. So what I mean by that is that we're going to set up this ratio of AD, okay, which is this side, over CD, the altitude, equals the altitude over dB. So AD over CD equals CD over dB. Now, why do we do that? Well, think of this as being two separate smaller triangles, this triangle and this triangle. And if I want to set them up to where they're proportionate, this AD is the smallest side of this small triangle. The CD is the smallest side of this triangle. Right now I'll put a 1 and 2 in here, so I can say triangle 1 and triangle 2. So AD is the smallest side of triangle 1, CD is the smallest side of triangle 2, so that's why I put AD over CD. Now CD is also the second largest side of triangle 1, so I want to put that in the numerator over the second largest side in triangle 2, which would be dB. So that's how I get this proportion, and this is how you find the geometric mean. So for example, we have a problem here that has a triangle where I'm trying to find y. I know it's a right triangle, I know this is a right angle, and this is the altitude, so I want to figure out what the geometric mean is. Okay, I want to figure out that y. So I'm going to set it up by saying 4 over y equals y over 5. So if I have that all set up here, I need to cross multiply. So we're going to use our skills of ratios to cross multiply here and say y squared is equal to 20. Now we're going to be using our knowledge of simplifying radicals. We're not using calculators. We're just going through and we're going to simplify this radical. And the reason I know I'm going to need a radical is because in order to find just y, I'm going to need to take the square root of both the sides here, which would leave me with y equals the square root of 20. I need to reduce the square root of 20. So I need to split it up into two separate radicals, one of them being a perfect square, which would be 4. And now I can continue to simplify by turning that perfect square into a whole number. 2 times the square root of 5. So that is the length, or the geometric mean, of this triangle, or the length of y. So again, the geometric mean is helping us figure out the length of this altitude, this y. Let's look at another example. On this example, I've extended the same concept of figuring out what y is, which is what we did on the last problem. So I have the same numbers, 4 and 5, but now I want to figure out what the value of x is, and I want to find out what the value of z is. Now, we can go through and we can figure out exactly what, we know that y is going to be the square, or 2 times the square root of 5, which is fine. But in order to find my value of x, what I'm going to do is take this 4, the smallest side of this triangle, this small triangle, and put it over x, which is the smallest side of the large triangle here. Think of this as being one large triangle. So small side over small side equals, now this also represents this x, the hypotenuse of triangle 1, the small triangle. So if I'm going to put my hypotenuse here, that means I want to put the hypotenuse of the big triangle in my denominator. All right, so everything that is in my numerator is from triangle number 1. Everything in my denominator is from triangle, we'll call it triangle 3, but that's the large triangle. So those are my rows. My columns are, like for example, the 4 is representing my smallest side. So 4 represents the smallest side in triangle 1. X represents the smallest side in triangle 3. X represents the hypotenuse of triangle 1. So this is the hypotenuse. And then this 4 plus 5 represents the hypotenuse of triangle 3. So see how everything in triangle 1 is in my numerator, everything in triangle 2 is in my denominator. We're keeping these ratios in these proportions. So I should be able to go through and say x squared is equal to 4 times 9, which is 36. What number squared equals 36? That would be 6. So my x value here would be 6. Now if I wanted to find the value of z, I put myself now in a position where I can say 6 squared plus z squared equals 9 squared. Because I'm working with a right triangle, I can use the Pythagorean theorem to find the values of x and z. Now at the beginning of the assessment in class, we're going to it's going to start out by saying what is the geometric mean of these two numbers. So for example, we have the numbers of 9 and 24. Think of those numbers as representing like 4 and 5 here. 9 and 24 representing there, because the geometric mean is helping us find that altitude. So I'm going to start this problem out by saying 9 over x equals x over 24, just like I would if I was trying to find the altitude. So if I cross multiply here, I have x times x, which gives me x squared. I have 9 times 24, which gives me 216. Now, in my calculator, I can go through and say the square root of 216, but it's not going to be a perfect square. So I need to think of numbers that I can divide into 216 that would be a perfect square. So I think of, okay, I have 216, so 216 divided by 4. Okay, that's 54. That could work. I'm going to keep going higher because I want that highest perfect square. 216 divided by 9. That works, 9 and 24. Let's keep going. 216 divided by 16. That's no good. 216 divided by 25. We know that's not going to work because this is not obviously a multiple of 25. 216 divided by 36. We might have a winner here because what I can do now is divide that 216. Again, I'm taking the square root of both sides. So I'm going to divide that 216 into the square root of 36 and the square root of 6. So my geometric mean in its simplest radical form would be 6 times the square root of 6. So again, just cross multiplication, getting my number, my product, taking the square root of that product, and simplifying that radical. Now this is the problem we're going to begin in class. When we start class over this section, I want you to go ahead and see if you can solve this. Remember, this is triangle 1, this is triangle 2, the big triangle is triangle 3. This is just like the example on number 2. Just different numbers are represented here, and we might have some quadratic formula issues, you never know. So go through and solve this problem, and we'll talk about it at the beginning of class.